Hello everyone. In this video lesson, we'll talk about capacitors and inductors in an AC circuit. በAC circuit ላይ capacitors እና inductors እንዴት behave እንደሚያደርጉ የምናይበትን ትምህርት እናያለን። Capacitors in an AC circuit, when a capacitor is connected to an AC circuit as shown here, this is the AC source. It produces instantaneous voltage equal to V max sine omega t. According to Kirchhoff's rule, the sum of this voltage and the voltage across the capacitor must be 0. So the magnitude of the voltage across the capacitor turns out to be V max sine omega t. This Vc is instantaneous voltage across the capacitor. To derive an expression for the current, we start from the definition of capacitance. C is Q over V. Capacitance Q over V ተብሎ ነበር ዲፋይን ይደረገው። ስለዚህ ክሮስ ማልቲፕላይ ብናደርግ Q is equal to C times VC ይሆናል ማለት ነው። VC ስንል voltage across the capacitor ማለት ነው። And that is C times V max sine omega t. Do you remember how current was defined? Current is defined as the derivative of just delta Q over delta t. We use derivative dQ by dt. D by dt, the first derivative of this expression, V max C times V max sine omega t. So C and V max are constant values. We pull them out and we write C times V max d by dt sine omega t. But the derivative of sine omega t is cos omega t times omega itself. So omega times cos omega t is the derivative of sine with respect to time. So using this, IC equals omega CV max times cos omega t. But this value is maximum value for this expression. Therefore, we write I max as omega times C times V max, and we write IC as I max times cos omega t. With a capacitor in an AC circuit, we started from voltage equal to V max sine omega t, and we have seen that IC, the current, is I times cos omega t. These two expressions are differently expressed. This one in terms of sine and this one in terms of cosine. Therefore, this voltage and current are not in step. We say they are out of phase. To determine the phase difference between VC and IC, we write this expression Im cos omega t as Im sine omega t plus pi over 2. Because cos omega t means sine omega t plus pi over 2. Therefore, the voltage is V max sine omega t and the current is I max times sine omega t plus pi over 2. They are not in step. They are out of phase. In this case, the current has plus pi over 2 here. Therefore, the phase difference between IC and VC is pi over 2 radians or 90 degrees. So the current is pi over 2 radians or 90 degrees out of phase with the voltage across the capacitor. And we say the current leads the voltage by pi over 2. Because we have pi over 2 expression for the current, so the current leads the voltage by pi over 2. Or the voltage lags behind the current. The voltage lags the current by pi over 2. In terms of graphs, if this is the voltage curve, the current curve should be this one. When the voltage is 0, the current is maximum. When the voltage is maximum, the current is 0. When the voltage is 0, the current is maximum. They are not in step or they are out of phase. And in this case, for the capacitor, the current leads the voltage by pi over 2 radians. If we say I max is omega C times V max, we can write V max over I max as 1 over omega C. But the V over I expression, voltage over current, resistance የሚባል ነገር ነው የሚሰጠን. But in this case, we don't say resistance, we call it reactance. For a capacitor, capacitive reactance, and we represent it by symbol XC. XC, capacitive reactance, it's 1 over omega times C. It's defined as capacitive reactance, and for omega, 2 pi f times C. And how does XC vary with F and C? When the frequency is large, XC will be small. When the capacitance is large, XC is also small. When frequency large, frequency ትልቅ በሚሆንበት ጊዜ ብዙ ከረንት መንሸራሸር ይችላል ማለት ነው በሰርኪት ውስጥ ባክ ኤንድ ፎርስ ብዙ ከረንት ካለን ሬዚስታንስ አነስተኛ ነው ማለት ነው። እዚህ ጋር ሬዚስታንስ አለ ምንለው ሪአክታንስ አነስተኛ ነው። When the capacitance is large, the capacitor tends to accumulate more charges. ብዙ ቻርጅ የሚያዝ ነገር አለው. There will be more current in a circuit. If there is more current in a circuit, then the resistance is small ማለት ነው. ይህንን relation በደንብ ማየት ይኖርብናል. When inductor is connected in an AC, as we said, the voltage source produces V max sin omega t voltage. And the V and the VL must be the same according to Kirchhoff's rule. V and VL, they will have the same magnitude. The potential difference across the inductor should be the same as the potential difference across the source, which is V max sin omega t. የከረንት ሪሌሽን ለማምጣት ምን እንጠቀማለን? self induced EMF የሚለው ነገር እናስታውስ. If there is change of current in an inductor, there is induced EMF, back EMF in the inductor given by E is equal to L delta I over delta t, if you remember. That delta thing is represented by derivative in our case. So V voltage is L di by DIL, the current through the inductor, by dt. The voltage is V max sin omega t over L. We write it as V max over L sin omega t times dt. Crisscross እናደርገው እቺን እዚህ ጋር ስናመጣት DIL V max over L sin omega t times dt ይሆናል. So integrating both sides, integral calculus ብንጠቀም ይሄን integrate ብናደርግ we get IL. When integrate this one, these are constant numbers, we pull them out, integration will be for the sin omega t dt. From your knowledge of mathematics, I hope you know that integral of sin omega t is minus 1 over omega times cos omega t. So IL is V max over omega L times cos omega t. This expression is a maximum value for this one, so V max over omega L, and IL is equal to minus I max cos omega t. To compare the current with the voltage, just like we did for the capacitance, we write minus cos omega t as sin omega t minus pi over 2. So the current is given by Im sin omega t minus pi over 2. Now, for the capacitance, the voltage and the current are out of phase. Why do we say so? Because the voltage is expressed by Vm sin omega t, while the current is expressed by Vim sin omega t minus pi over 2. This is omega t, this is minus pi over 2. So the current and the voltage are out of phase, and the phase difference between the two is pi over 2 radians or 90 degrees. As this is minus pi over 2, in this case, the voltage leads the current, or the current lags behind the voltage by how much? By pi over 2 radians. Graphical representation of this one will be the voltage given by sine, the current by sine but minus pi over 2. Minus pi over 2 will start from here. When the voltage is 0, the current will assume negative value here. When the voltage is maximum, current is 0. When the voltage is 0, current will be positive. It will continue like that. This is very important concept. Again, just like what we did for the capacitance, the I max is V max over omega L. Omega L is V max over I max. Omega L, V max over I. But V over I is kind of resistance. Here in this case, we say reactance. So inductive reactance. XL is equal to omega L is the inductive reactance. And for omega, 2 pi F times L, as the frequency increases, as the rate of change of current increases, the opposing voltage will increase, so the opposition will increase. So they are directly proportional. As the self-inductance increases, then the opposition also increases, and XL is directly proportional to L. So how do you relate XL with frequency and L? It's directly proportional to F, and also directly proportional to the self-inductance. We have a table of summary for what we discussed so far. For a resistor, we call resistance. For a capacitor, we call capacitive reactance. For inductor, we call inductive reactance. Capacitive reactance, 1 over 2 pi Fc. For inductive reactance, we have 2 pi times Fl. For resistor, please look at the previous video. We said that the voltage and the current are in phase. There is no phase difference between the current and voltage. They are expressed similarly. But for capacitance, the current leads the voltage, so the voltage lags behind the current, and we have negative here. And we'll explain this in detail when we talk about phasors in the next video. And in this case, the voltage leads the current by pi over 2. You have pi over 2 or 90 degree out of phase angle is represented here. To remember which one lags and which one leads, you have one mnemonic, very important thing that physics students always use to remember this. If E is for voltage or EMF and I is for current, then Eli, the Iceman, will remind you of which one leads and which one lags. E is voltage. Where there is L, where there is inductor, the voltage leads the current. When there is capacitor, the current leads the voltage. And this is very important mnemonic. And thank you so much. In my next video, we will discuss phasor diagrams and we will use them to analyze RLC circuits. Please write your comments and subscribe for more video. Thank you.